Hello everyone. In this video, I will be talking about the concept of interface in general in the programming world or in computer science, you can say. And then I'll be talking about how a particular language, in this case, Go, uses interfaces because Go is primarily an interface-based programming language. It does not have the concept of all the object-oriented programming like any other purely object-oriented program like Java. So first of all, let's discuss about the concept of interface, and then we'll talk about how Go uses it, and also we'll see how you can use interface in Go and various types that are associated with it, like asserting the type, or how you can embed or extend them, how you can use, and also a few small example. And also at the end, I will be talking about the real life practical use of programming and production grade softwares, that how, and then only you will be able to realize how powerful this concept is, uh, and how this relates to various famous architectures of programming like clean architecture in solid principles, how they are used. So first of all, let's talk about the concept. So what is an interface? So interface is basically a way in which two seemingly unrelated entities interact with each other. So let's say a TV remote. So a TV remote is basically an interface between you and the TV. How you can interact with the TV using the remote. Similarly, you will be hearing about the term API a lot these days in computer programming in software world. So what is an API? API is application programming interface. It is again an interface between two different phases, you can say. Like you can broadly classify all the softwares in two major division. One is front end, one is back end. Front end is the one that you can see, you can interact with, and back end is the one where the processing and all happens. So the one that glues the front and back end together is the API. So this is again an example of interface. Now, this interface in programming, in purely in coding, how we use it. So interface basically enlists the functions that a particular type can do. What I mean by that in simpler terms is, let's say, so what are the things a human can do? If I can define a type, let's say walking, talking, eating, these three, so we can say that whoever can do these three things is a human, just an assumption. So now humans satisfy this thing. So we have implemented the interface which has the three functions, three abilities, and we have implemented them. So in interface, you basically define what are the things a type can do, and then the type will implement them. So interfaces are not implemented. Interface just defines what are the things, what are the capabilities of some type, and any type can implement it, showing that I can do it. This example would be more clear when we look at the code. So let me show you a simple example of an interface, how you can use an interface in Go. I'm using an editor called Vim. You can use any editor, of course. So the first line is the one you say main. So I'm not going into the basics of programming in Go. Maybe I'll add more videos about the basics of how you can code in Go. But this is about the concept of interface and how you can use it. So it is, you can say, fairly advanced in Go, but there are many resources where you can catch up on Go. So how you define the interface is, let's say, type, let me name it, um, what can you say? Type homo No, that would be too crude. Let's say human. This is definitely not a good way to name, because ideally the naming convention in Go is that the interface name should end with ER. So if the interface is about all the walk that a person can do, so maybe the name of the interface can be walker. So this is just an example. I'm not going into the standards. Let's say walk. And this function maybe takes an integer and returns an error. Maybe it can be anything. Then maybe talk, which doesn't take anything and returns nothing. Maybe these two. Then I can create a type, let's say, uh, which is a structure. It can be anything. Structure is also one type. It can be a string, it can be integer, it can be any type that can implement this. So let's say it has a first name type string and last name. In the main, what I'll do is maybe name it person. Let's say P, which is of type person, whose first name is, let's say, Savik, which is my name. Last name, let's say, is Haldar. I made a spelling mistake there. It would be interface. I can show you more about my setup in some later video, that how I've set up Vim for Golang development, that it is showing errors, this red marking on site to show you that there is some error, something like that. Maybe in some other video. Now let's say there is a function which takes an argument h of type human. That's notice carefully that it is a function which takes argument of type human, not of type person, and it prints, and it just does h dot talk. Oh, let's say I'll take this later. So I've created an interface, we have created a type. Now how this structure of type person can implement the interface human is, we won't be using an implements keyword like in languages used like Java, but how Go does is it does it implicitly. You you just define the methods of the interface and it will be implemented implicitly. What I mean by that is that uh, we'll create a function which takes p of type person and it defines walk. It takes I as integer or any value for that matter and returns an error. What I'll do is that I'll say first name, last name, I'll do walks. What is the first argument to it? P dot P dot first name, P dot last name. You see that FMT is a package that I haven't imported, but it will import it automatically, I guess. Yes, it does. and it has to return something. In this case, I mean, I was just for an example showing you that we will return an error, but in this case, there's no possibility of returning error, so we'll be returning nil there. So this is something called method. Method are function which are defined on a type, in this case, a person structure, and then p of type person, we will define this method talk, which doesn't take anything, return nothing. This will also do. Talks, providing the arguments p dot first name, p dot last name. Now you see that we have defined this too. Now what we can do is that we can say p dot talk. We can say p dot walk. A walk, we need to pass an argument here, but this is not required. We can also say that just to make use of the integer passed is I. This was just to make use of it. Logically, you won't be passing useless values. And here you can see we should have used the returned error. It is telling that we have some. Oh, I see. We are using format string, but we are using ln. Ln is the not the method of fmt package which takes format integer. It just prints and appends an empty line. What you should use is printf. That takes formatting. That is where it was showing this error. This plugin that I'm using is called GoVim. This is a Vim plugin that is written in Go. You should definitely check it out. It's a very good project. Anyway, it's time to run our program. I'm not sure where it is stored. It is stored in home. Okay. So how you can run a Go program is go run the file name. So you see, and also we could have added some line gaps so that it looks good. How you can do is that backslash n. With ln, you don't need to pass backslash n. Now if we run, you see it is executed. But now you might be thinking that what was the use of it? We didn't do anything productive with it. Now let's say we want to generalize it. Let's say there is another type which does type dog. Let's say the dog has a name. Now this also needs to define the two methods in order to be eligible to use the interface person. Sorry, human. Dogs are human. So don't go about the terminology. I have used bad names. You should logically use better names. How we'll implement dog? Maybe df type dog, which first implements walk, takes an integer. This is the type. Maybe we can say works. Name can be d dot name. Return nil. We ideally shouldn't have used this type. I mean, this is useless. So let's remove this integer because you see there's no use of this in this particular use case. Also, we don't need to pass an error. Okay. Edited the type. Don't need to return an error anymore. Define the walk method. Now, talk method. This is similar. This is obviously an example, so not much use here, but trying to explain the concept. Talks. Now you can again create an type anything. The name is, let's say, Tom, anything. Now we can say d dot talk d dot walk. We should have added the backslash n's to append an line, otherwise it would look bad. Now you see, this is how you can run it. But now let me show you the important use case, like how you can do polymorphism in it. Now let's say we have a method function walk and talk. Now what you can do is pass it a type of human, and what it would do is that it would do h.talk, h.walk. Now the good thing about it is that now you can pass different types to it, and the type that you pass would be the one that would be executed. So you can pass different messages and they would be interpreted in different ways. So let's say we pass let's say we pass uh, walk and talk can take a type of human, and since dog and person they both satisfy this interface, we can pass any type there. So you see polymorphism. This is the concept of polymorphism. Walk and talk, if you pass it of type p, you see, now we just passed it the type of, now as you see we passed it a type of type human, type person, it worked. Now if we pass it if we pass it a type of dog, it will do the same. So basically, it can take different types and execute it accordingly. So that should let you know that how the basic example of how interfaces work in Go. Um, we can talk a bit advanced topics as well. Like let's say this worked this way. But what we can also do is I'll explain your concept of empty interface. Let's say we have a function which says do it anything. It takes I, which is of type empty interface. And what it does is well received I. So now I'm going to talk to you about what is this empty interface. So empty interface is an interface which does not have any method. So what is the use of it? So as we talked that if an interface, let's say, have two methods and the type defines these two methods, then we say that this new type implements that method. So these two are essentially of the same type. Like in this example, we saw human interface. There was a type of person, there was a type of dog. Both implemented it. So essentially, they both become of the same type. As we saw in walk and talk method, it was taking of type human, but we were able to pass both the types of person and dog. Similarly, if there is an empty interface, there is no method at all. What does it mean? Then any type can basically implement that empty interface because empty interface does not have any method. And every type implements no method because there is no method. So it's quite interesting. So since all the types can implement an empty interface, so all the types can be said of type empty interface. So empty interface is a way in which we do dynamic programming, not dynamic programming, dynamically typed languages like Python. We can have that feature in Go. So basically, there is no strict type check. You can pass anything and that would work. So do it can take empty interface type, which means you can pass it value of any type. So you can see if we execute this method, do it, pass it integer value of let's say 4. Oh, I think I haven't saved it. So you see value received is 4. We passed it of type integer. Now let's say we pass it some name, let's say Gauri, just a random name. So you see value received Gauri. So this is, we talked about empty interface. Now we can also talk about type assertion because as you see, we can pass it in empty interface, we can pass it of any type. So we need to assert it. So what we can do is that we can convert it into a string type, a strictly string type, str, which is a type string. How we can pass it the value? String would be I, and how you do type assertion, the syntax is dot the type. Now if we do it str, you can see if we execute, it works fine. We have asserted it to a strict data type, strict string type str. But if let's say we passed it a wrong value instead of string, we passed it, let's say, again, 5. So assertion would fail. But this is something we need to take care of. So if we run, you see there is an error. There is a panic because we tried to assert a type which is not possible. So what we can do in this case is that we should always check using a separate value. So if it is not okay, then only we'll proceed. If it is uh, not okay, we would return. So you see, we averted this. So now we see that we have covered the topic of empty interface, what is an interface, how it is syntactically, how you use it, a simple example, polymorphism, and we also talked about how you can do dynamically typed programming in Go using empty interface, type assertion. Um, Now, anything else I can talk? And also, you can, so there is no way you can extend an interface like in other languages support, but we can definitely embed. Let's say there is a type which say an universal name needs to be used here. Maybe superhuman. So, oh, I think that's a good example. So, a superhuman is a human with extraordinary abilities. So, what ability does a human not have that a superhuman might have is, let's say, fly. So, whichever type can have this, we will say that it is a superhuman. So, let's say there is a type Superman is a struct with no what extra property it can have is that no, that would be a bad example. Mm, Anything, let's say uh, where underwear outside, which is of type boolean, and the extra method that we can have is it would have everything that the person can do. In addition to it, it would have this ability to fly. And what I would do is that is Superman is wearing underwear outside. We'll see whether it's true or false. That's a weird example, I know. Need to do some editing here. We can say Superman walks Superman talks. Sorry, what I mean by embedding the interface is that it has the method extra method fly, but it also we need to embed this human. So this is a very good example, I think. So superhuman is a human with the extra ability of flying. So we can say if we take a method function do everything, it takes a type of superhuman. What are the things we can do? S dot fly, s dot dog, s dot walk. These are the things we can do. So fly didn't have anything related to flying, so let me add this. Superman is flying. Sorry. So let's create a Superman type. S is a superhuman with outside as true because he is wearing it outside most of the time, but these days I think he's wearing it inside. But let me comment these two out for the time being. What we'll do is that we will pass it to do everything, an instance of superhuman. $31. Oh, I'm sorry. Yeah. This is not applicable here because this is a new type. So in this Superman struct, you see we don't have this first name, last name things. Oh, I'm really sorry. The type needs to be Superman. We are creating an instance of Superman. I did it superhuman by mistake. It needs to be Superman. Let me comment out this dog type for the time being. Now you see, this is composition. We embedded the type, we extended the functionality. So human is already was an interface. We added this type. We created a superhuman interface using the human interface. This is how you can do embedding. And there are multiple more things that we can talk about, but I think this has covered a very big crowd. of interface in Go. Now let me talk about a practical application of interface in Go. So now let me talk about a very practical application of this interface type in Go, which I'll just talk about and I'll not show you because it requires a lot of ground and maybe in a separate video, is that you can abstract the details. So a very famous architecture of software programming says that implementation details needs to be abstracted. What are the implementation details of the software? Like what is the database being used, and these things like what is the message queue being used. These are the implementation details. The logic should not be worried about that. So what you can do is create an interface which will have the methods that the database can do. And later you can pass it types of different databases, like pass it an instance of Redis when Redis implementation is required, pass it an instance of MySQL when MySQL type is required. And this is how you abstract the implementation details. And at a very high level, let me tell you why abstracting the implementation detail is required is because if you can abstract the implementation details, then you can swap different technologies being used at different runtime with very less amount of code being needs to be addressed. So let's say now my application use case requires Redis type, but later on it might be that I need to use Postgres. So with this type of programming in which you abstract the implementation detail, you can easily change the types. And also if you abstract the implementation detail, then even it becomes easier to read through the code base because now you're not worried about how this is being handled, how the very low level implementation details are handled. What you need to worry about is the business logic, and business logic is something that keeps on changing very rapidly. So that is the one our focus should be at. So I hope this intermediate to advanced level of talking about interfaces in Golang was useful. If you have any doubts, please leave it in the comments. I'll try to reply it there. Maybe in later videos, I'll cover more grounds. So that was interface for you. The next video that I will be releasing is something called solid principles, a programming principle that any language needs to use when it is dealing with production grade software. There, this concept of interface would heavily be used. So thank you for watching. Please leave questions in the comments. Thank you.